welcome to our fifth lecture of this book. So, today we are going to start a new chapter called Overview of the Patterns. So, in the previous chapters, we learned about the promises and pulse of distributed systems. Now, in this chapter, we are going to understand some of the overview of those patterns. So far we have discussed like distributing the data means at least doing partitioning or replication with the data. So, to start our journey through the patterns in this book, for now we are focusing on replication part. So, let's start directly and we'll jump into one example. So, imagine you have a very minimal data record that captures how many widgets we have in a four different locations. So, for example, in Boston we have 50 widgets. In Philadelphia we have 38 widgets. In London we have 20 widgets, and in Pune we have 75 widgets. Now we want to replicate it into three different nodes called Jupiter, Saturn, and Neptune. So replication is nothing but holding another copy of the same data in different zones, which is we are doing here. So the first area of a potential inconsistency can appear without any distribution at all. So for example, consider a case where the data for the Boston, London, and Pune are held into three different files. Okay, in that case, performing a data transfer of 40 widgets, meaning changing the Boston.js to reduce its count to 10 because previously it has 50. Now we are transferring 40 from here to Pune. So we'll decrease the count by 40 from here, and the final count will be 10, and then changing the Pune.json to increase its count by 150. We are adding 40 actually. But what happens if the Neptune, where the data is sitting, crashes after the changing Boston file, but exactly before updating the Pune's one? In that case, we have very inconsistent data destroying 40 widgets, which we never want to happen. Similar example we can understand is, let's suppose you are transferring some money to your friend, and you transfer, let's suppose, 50 rupees to your friend, and 50 rupees got debited from your account but never got credited into the your friend's account, which is very bad situation and you never want to do that. So how bank and all these people solve this problem? So a very effective solution that we have is write ahead log. This is a very simple and very cool approach that all the transactions do to make sure everything is in atomic state. So for example here, let's suppose client requested 40 data transfer from Boston to Pune. Our handler saw that request and created a log file out of it. I mean, added everything, the current state, into a log file, and then responded back to the client that, hey, I'm doing the part. And then the update happens, like the updater, which is the actual logic which updates our data, reads everything from this log file. So it will read like what operations I want to do. For example, 40 data transfer from Boston to Pune, and then it will read the values of our boston.json file and then pune.json file, and store the current values into our log file. Then after, we'll start the actual job, I mean transferring the data. So 40 we transferred, we reduced from our Boston file, and now while we were transferring it to the Pune file, the database crashed. Okay, so in that case, how will we handle it? So an effective solution is write ahead log. In this, we have update to the log file. So basically, this is a single write operation, right? So it's very simple to ensure that it's done automatically, atomically. So when you do this, it should be atomic, and it's very simple to assume that it will be atomic because it's a very simple write operation, which can be done in one go. Once the write is done, the handler can acknowledge to its caller that it has been handled the request. Now the handler or the other component can read the log entry and carry out the updates to the underlying files. For example, what we are doing here. So for example, now Neptune crashes after updating the Boston. The log should contain enough data so that we can always, after the restart, we can always figure out what happened, and we can always come up with a consistent state as before. In this diagram, we can understand like when we whenever we log, like in the log file, first we added what operation we want to do. Then later we also added all the values that we got from the boston.json file and pune.json file. We have stored all the current value into our log. So for example, when something crashes and we restarted the system, we had the whole information, what was the initial state of boston.json and pune.json. And we can figure out, okay, so boston.json has been already decreased, but the pune.json has not increased. So we can increase it by 40 and mark the operation as complete. Or either we can revert our this reduce thing and we can always add plus 10 or do something so that we can get back to the initial state as before, because we already have the whole information what all needs to be done, what was the initial state when we started the operation, and what are the mid state that we are in right now. So if we have everything in hand, we can always like get back to the previous state or the original state we want to go, or if we want to move forward, we can also move forward. So the logs gives us very resilience, because for a prior state, the linear sequence of changes determine the state after the log is executed. So this property is important for resilience in a single node scenario. But we will see it's very valuable for replication. If multiple nodes starts at the same time and they all play the same log entries, we know we will end up with the same data state 2 again with the same previous issue that we had. So databases use a write ahead log as discussed in the above example for to implement all the transactions. So whenever we do like bank transaction or anything, or even in this databases we do like transaction, start transaction, end transaction, in that case the behind the scene we use write ahead log. So we have whole chapter around it in the later lecture, later like part. So we'll go through that very in depth in the later one. For now we'll stop here and we'll move to the next.